welcome to today's lesson. Today we are going to draw, sketch quadratic functions, and identify key features. Our language objective is to explain what are the key features of a quadratic function and how to find them. So let's take a look at today's do now. Let's take a look at today's do now. Complete the table. Pause the video, complete the given table. Alright, so here is my table complete. What I did was I input the given function into my calculator and found the y values for every given x value. Our thinking for today. What are the key features in a quadratic function? Quadratic functions. A quadratic function or quadratic polynomial is a polynomial of degree 2. The graph of a quadratic is always a parabola. A quadratic function has the form y equals ax squared plus bx plus c. This is known as standard form. So some of these special characteristics or the key features as we will identify them are: we will need to identify the y-intercept, which is always going to be 0, y. We will need to identify the roots, also known as the x-intercept, and those points are always x, 0. We will need to identify the vertex and also this dashed line that actually passes through the vertex. So I'll start with that one. This dashed line, this vertical line, is known as the axis of symmetry. It is an equation that is x equals negative b over 2a. Now what are a and b? It all depends on your quadratic. The vertex is actually the point containing the x value of the axis of symmetry. This is also known as the turning point. So if I look at the do now, I know that the vertex is this point 0, 0. How do I know that's the vertex? Because all other y values on the left and right of it start repeating. So that is how the vertex is found. The vertex is also special because it will be a minimum or maximum point. A is never equal to 0. The sign of A shows whether the function concaves up or concaves down. How do you know when a function concaves up? It's going to look like a regular U-shaped parabola, and the value of A here will always be some positive number. I know that a parabola is going to concave down because I'm going to have an upside down U, and here the value of A is always going to be some negative number. So that's how you can tell whether a parabola will concave up or concave down. So example number 1, we want to draw or sketch key features using a quadratic function. Answer the following. Part A wants us to draw the given function y equals 2x squared minus 12x plus 10. B, determine whether the function concaves up or down. C, write the equation of the axis of symmetry. And D, identify the domain and range of the function using interval notation. So what we are going to start off with is, I am actually going to start off with part B. Does the function concave up or down? That's easy to answer because I am identifying the value of A. Here I have a positive 2. Since I have a positive 2, this function will concave up. So what I'm going to see is a regular U-shaped parabola. What we are going to do for part A, our drawing piece, is we need to identify the key features. What are our key features? The intercepts, the vertex, and the axis of symmetry. So I am lucky here because this is a calculator question. All I'm going to do is input this into my calculator to find all of those key features. All right, so I am going to start off with my y-int is 0, 10. I am going to identify my root or roots. In this case, I have 2. I am going to find my vertex, my turning point. And my axis of symmetry is always the equation x equals whatever the x value is on the vertex. All right, so here is our parabola. My axes. I'm going to plot my intercepts and my vertex. And I'm going to create my U-shape and then plot the other point. Don't forget, it is a U-shape function, so you want to make it as parabolic as possible. All right, so there's my U-shape. Let me identify my key features again. So here I have the point, my y-intercept is 0, 10. I have my x-intercepts at 1, 0 and 5, 0. And I have the vertex at 3, negative 8. I am going to draw in my axis of symmetry, and that is the equation x equals 3. And I am done with my drawing piece. For part C, we want to write the equation for the axis of symmetry. We already know what the axis of symmetry is. I am going to do this algebraically using the formula I gave you. So for part C, the formula says x is equal to negative b over 2a. Now, what is the value of b? B is negative 12. And we need to know the value of a, which is 2. I am going to input these values into my formula, and I should get x equals 3. And I do. So x equals 3 is my axis of symmetry. For part D, we are finding the domain and the range of the given function using interval notation. So the domain of any polynomial is always all real numbers, so negative infinity to positive infinity. The range for this function starts at the minimum y value, which is right here at negative 8. It is included, and we are going to positive infinity. All right, let's look at example number. The function f is given by f of x equals x squared minus 2x plus 1 for 0 is less than or equal to x, which is less than or equal to 4. Part A, sketch the graph of f. Part B, find the inverse of f. And on the same set of axes, we want to sketch the inverse. All right, so this is a no calculator question. We have to do this manually. They gave me a domain, a restricted domain, in which we are only working from 0 to 4, where my x values are just 0 to 4. So I'm going to create a little table here. So what happens when I input 0 for my x? I get a value of 1. What happens when I input a 1 for x? I get a value of 0. And I'm just doing input-output. And we're going to plot these points. So we have 0, 1, 1, 0, 2, 1, and so forth. So if you notice here, I did not put any arrows at the end of this function. Why? Because we had a restriction here. Part B says to find f inverse. Now let's think back to inverse. If I were to draw a horizontal line on this parabola or a piece of this, I see that this is not one-to-one, therefore it does not have an inverse. So what they actually want us to do is they want us to use these values of f and create the inverse. So what happens with inverse? The x and the y values swap. So I'm going to plot these coordinates on my grid. All right, so now that I have that, this point here, we won't be able to graph. So how does this look? This would look start at 1, 0, go to 0, 1, and it would shift on this side. So this is how this inverse would look graphically. Last one here, we have on the same set of axes, sketch the graphs of the following functions. We have f of x, x squared, and g of x, x squared minus 2. They gave us restrictions. For each function, write down the range for the given domain, and we want to look at the intersection point with the line y equals x. So again, I noticed that this is a calculator question. All I need to do is input this into my calculator to plot the points of f of x and of g of x. So this is f of x. There is my parabola g of x. So we want to find the range of f of x and the range of g of x. The range would be what is the lowest value of that f of x function. In this case, that would be 0. And it goes all the way to 9. So 0 is included, goes all the way to 9. For my g of x function, minimum point is at -2 and goes all the way to 7. So that is the range of the given functions. We want to determine the point of intersection or points of intersection with the line y equals x. Y equals x is the line that crosses the origin. So here I see 2 points for the f of x function and 2 points for the g of x function. And that is it. Keep learning, keep growing, and I will see you in our next video.